Okay, welcome to our Verilog code walkthrough. Our first module we'll be looking at is our system controller. This is our top module that has all the other modules referenced inside of it. So we have our I/O here, as well as the four other modules that we're going to be interfacing with, and these are the wires that run between them. One of those you can see at the bottom is our VGA control. So our VGA control basically controls everything that has to do with outputting to the VGA display, aside from handling the vertical and horizontal sync. And so in this, one of the interesting snippets is these large blocks of code right here. So these are different regions on the display that correspond to the different quote-unquote segments in our digits. So you can see that this is, for example, the 30s place. This right here would be the 5s place, etc. Down here, this is just our cute little face, and this is our C out gray block. And here is a very long always block that switches between them depending on our input from the ALU. Right here is where we have our VGA sync. That is simply just taking in a clock as well as a reset signal and outputting the X and Y positions as well as our VGA sync.
All right.
And then here's the LED controller. This is much the same. Takes in a clock, and then if it's not taking in the signal from the ALU, it is just flashing the lights back and forth.
And to quickly walk over through our decoder, as you can see, we added one more bit of instructions and functionality. So we took upon some of the instructions coming from Lab 2, and we just decided to have a little more fun with it and added some more logical and arithmetic operations. And from here, we will transition into the full ALU, where each of the opcodes are now outputted to the ALU out based on the instructions that we implemented. The one interesting snippet I would like to point your attention to is the use of the adder. Obviously, with the use of the adder, there is the possibility of a carry out. So we used a previous implementation of an adder. Before we go into that, though, this is just the module format. And as you can see, we have the C out for the carry out bit. So that when you see in our later part of the video, you'll see a gray box indicating the carry out. And this is our module for the adder, and as you can see, we're accounting for all the cases to make sure that all bits are added properly and that we properly account for the carryout bit whenever there is an overflow.
Okay, so this is our demonstration of our code working on the FPGA. The first 5 switches are 5 bits for A, next 5 are 5 switches for B. The next 5 switches go through our different operation modes, and the last one is our display mode. So we're going to leave the switches as they are for now because we don't have enough time to test all of them. But for our operation modes, right now it is as A inverse and B, A inverse or B, A inverse, B inverse, A and B inverse, A or B inverse, A NAND B inverse, A NOR B inverse, what is this? A inverse NAND B, A inverse NOR B, A and B. We got A or B, A NAND B, A NOR B, A XOR B, A X NOR B. Now we switch over to the other one. All right. Negate A, negate B, B minus 1. You know, let's switch display modes. So now we have the results up on the screen, and the LEDs flicker back and forth. So what do we got now? B plus 1. And then we have A plus B, A minus B, A, oh my gosh, plus 1, a minus 1 a times b, b minus a plus 4, a minus 4, a plus 2, a minus 2, b minus 2, b plus 2, and that is it. And draw your attention to the fact that we have, let's see, an overflow bit indicated right here by the gray box, and an LED mode is indicated as our last LED.
So as you can see in our code, what we decided to do was add one more bit to the full ALU and the decoder. And by adding one more bit from 4 bits to 5 bits, we were able to add more instructions and functionality. And so as you can see in the previous part of the video, you'll see us going through 32 different cases, because adding that one more bit contributed to 16 more instructions that we could test out.
Yep, and then on the other functionality side, we are now outputting to a VGA display. We chose to use the VGA display because it was a little more fun than doing it on the 7-segment display. Now, some challenges we ran into this was specifically with the timing. We found that our horizontal sync and vertical sync were not quite working, and so these displays were just refusing to take an input, and so we had to just triple check our front porch, back porch, as well as our sync, to make sure that the display would actually take the signal. Another challenge was getting these shapes on it, and so that was a function of the X and Y scan and creating balance for each of these shapes that it would fall in between. I think that's it.
Yep.